Let me just share screen. Okay, so last time we were talking about the Gaussian elimination. All right, we derived a general formula, okay, for solving the Gaussian elimination. If you want to solve it with the computer, okay, with a program. So basically, the formula that we got is Aij at the step k here. Sorry, correct. Aij step k minus 1. Aij at the step k is equal to Aij at the step k minus 1 minus Aik over Akk. Okay, this is all at the step k minus 1. Yani, this is the old elements of the matrix, right? Multiplied by Akg, right? So, and I goes from k plus 1 till n. Okay, for the first step, okay, we used so these lines for 2 till n. Okay, and j goes from last time I wrote k plus 1 till n, it's from k till n, right? Or you can go from k plus 1 till n if you put zeros here on this column. I don't know, it's better. Okay, j goes from k till n and not from k plus 1 till n. Okay.
دكتور في بعض حدا بالويتنج روم.
And but people wait in the room. Okay. Okay. As you can see here, okay, for the first step, you take the j equals 1. For the second step, you take the after the first step, you get this. For the second step, okay, you will subtract the lines from 3 till n. Okay, you will modify the line from 3 till n, but the j equals 2, okay, till n, you subtract it. So it's from I going from k plus 1 till n, and from j equals k till n, okay? Last time I wrote here k plus 1, it's k, okay, it's not k plus 1. That's the only thing. So now if you apply this formula, right, you can write the program. So now I'll show you the program. All right, so that's the program. So for example, you define your matrix A here, okay? You define your vector B, and then n is equal the length of B, okay? Here it's a matrix 3 by 3, but I chose an example, but you can write the program that it works no matter what is the matrix here, right? So if I modify my matrix and my vector B, it should work. All right, so now this is the Gaussian elimination part here, okay? So this is the Gaussian elimination part. This converts your matrix into a triangular. So basically, what you need to do is a loop on K, a loop on I, and a loop on J, all right? So, and now what you need to be careful is that each time it's recommended to save the matrix A okay, at the previous step. So AB is, this is we are saving the previous matrix A, okay? Because as we are using the formula, we are modifying, okay, the matrix. So if you use here the same thing A, you will get error in your program. Your matrix will not be triangle. Right, so what I called AB here is the matrix A at the step k minus 1, yani right? And this is the new element for A. So you make a loop on K from 1 till n minus 1, right? Because you have n minus 1 step that you are doing to get your matrix diagonal. And then you go for I equals K plus 1 till n, for J equals K till n. And then you just apply the formula Aij is equal, okay, the previous matrix Aij, okay, element Aij minus Aik over Akk multiplied by Akj. And the same thing here for the vector B. Bi is equal Bi minus Abik or Akk Bb of k. And then here I get my matrix A and my vector B. And now here I will solve the triangular. So the triangular program, okay, I gave it to you yesterday. Okay, so you
Mhm.
start by the last element, right? And then you go from down till up, n minus 1, minus 1, 1, and then you calculate the sum, okay, aij plus multiply by xj, and then here for j equals I plus 1 to n, and then, okay, you uh, you get your vector x here, right? So على نصيحة مني لكم, don't learn these formulas by heart, right? They are complicated to learn by heart. That's not what's asked for you. What you have to know is how كيف تطلعون these formulas
مم.
from reasoning, okay? And so this is uh, not complicated to derive these formulas. So learning it by heart, you will make mistakes. This is sure, right? And this is also, I mean, this is simple formula. So and now if you run this program, right? If you run this program, let's just show you. Okay, so you get, this is the triangular matrix, and then this is the B after the triangular matrix, right? And this is the X that is the solution of the problem. All right, so now if you make A multiplied by X, you should get your, uh, sorry, here X is a vector, right? Uh, line here. So if you make A multiplied by X, you will have a problem. But you can like make A multiplied by X prime, or define your vector X to be a vector column instead of a vector line. So here you get 5, 5 minus 21. You should get the B here. Right? Yeah, you get the previous B, right? But here I modified uh, the matrix A, right? So if you take the matrix A defined as before, okay, because the matrix has been modified after the triangular, so just copy here. And okay, so this is my matrix A. So if I made and this is the B here. If you make A multiply by X, x is 1, 2, 3 here. A multiplied by x. Okay, yeah, we get 5, 10 minus 10, which was the b that I defined before. So you get the correct solution for your problem. So as I said, the Gaussian elimination relies on um, making the matrix triangular and then solving the triangular system of equation, the upper triangular system of equation. Okay, so it's not complicated. Now, what you could have done in MATLAB faster is to subtract the lines directly. So if you take, for example, here, instead of making a loop on J, I could have subtracted the line here and taking AI double point here instead of J is equal A, okay, I double point minus this multiplied by AK double point. When you put AI double point here, if I change here like this, all right, so this, it's taking all the line, right? So if I put the double point here, I'm taking all the column, right? So this is a fast way that you can do it in MATLAB. So subtract all the line, and when you subtract all the line, you don't have even to save the matrix, because you're when you do the loop on J, right? So this is where you need to save the matrix, because when you subtract all the line, it will automatically take the old values one shot, so you don't have to save even the matrix. So this is something you can do, subtract the line, but this is only available in MATLAB. So if you want to write this in C++ or Java or whatever, so you cannot do that. So that's why it's better to know to solve it completely, and then if you want to make it faster in MATLAB, you can just subtract the lines, right? Subtract the line I minus the line K, right? Multiply by this coefficient here. Okay, so this is for the Gaussian elimination. Okay, so now I would just like, I can say this. Right, so let's share a new screen. Okay, so now there is another method that is called the Gauss-Jordan method, which is similar to the Gaussian elimination. Okay, the Gauss-Jordan method consists, the Gaussian elimination, we subtracted the lines, etc., till we get till we got, in fact, a triangular matrix, and then we solve the triangular matrix of equation. So in the Gauss-Jordan method consists on converting the matrix into the identity matrix. Okay, and then you get immediately the solution of
each
x, because we are solving, what we are doing is that when you convert the matrix into the identity, okay, it means that you are multiplying by a minus 1, and the series of operation when you have the system of equation ax equals b. Okay, when you do operation and you apply it on b, all right, also, okay, you do operation on the matrix A to convert it into the identity, means that you are multiplying by A minus 1, and then you get directly, okay, on the B side, you get the solution, right? So A minus 1, right? So in the Gaussian elimination, we're not subtracting only the lines, but we are subtracting also the columns. So I will give an example. So let's suppose A is equal to 1 minus 1, 5, 2. Just I have some problems with my pad. So 2 and 3, 2, 1 here, and 2 minus 3 minus 2, right? And my vector B is equal to 5, 10, minus 10. Okay, this is the example that I used in the program, so the same matrix. So I should get x equal 1 to 3 here. Right? So in the Gaussian Jordan, also the Gauss-Jordan method, we also like concatenate here, okay, the matrix 2 minus 3, 2, 5, 10, minus 10, right? And we do the same thing. First thing here, there is 1. If the مكان عندنا 1, we have to divide this line by the AII here, A11, to get a 1 here on this line. Okay, normalize it by 1. Okay, here, what we do now, the same steps than the Gaussian elimination. So we do here L2 minus 3L1, right? And the same thing, okay, that we had before. So, and L3 is equal to L3 minus 2L1. All right, and now what we get is the following: 2, 5. All right, so here you get 0. Okay, L2 minus 3, so it's 2
5
minus 5. All right, so
minus 5.
1 minus 1, and 10 minus 15 minus 5.
كيف minus 1
So it's
1 minus
1 minus
minus 6
minus
minus 5
1 minus 6 minus 5 here, right? And here it's 10 minus 15 minus 5,
minus 5.
right? And here the same thing, what you get is
هذا
0.
بعتقد it's minus 2 بالماتريكس، يعني 2 minus 3 minus 2 بالgiven فوق. It's 2 minus 3 minus 2.
Here it's minus 2. Yes, thank you. All right, so okay, so what we get here is so minus 3 minus 2, so it's minus 1. Okay, minus 2 minus 2, so minus 6, minus 10, minus 10, minus 20.
Minus 20.
Right. Okay. So now what we want, okay, الهدف here هون is to convert, okay, to get the identity. So we want 1 here, okay, and so what we will do here, okay, is to divide this one by 5. So okay, L2 divided by 5. Okay, and I did, we can keep it, we can after divide by -1, right, when we finish diagonalizing. So we get 1 minus 1 minus 1. Okay, and now we want to subtract this. So we have L3 minus sorry, I yeah, okay, so L3 plus L1. Okay, so we get the 0, so we get the 1 minus 1 2 5 minus 1 0 1 minus 1 minus 1, and here I get 0 0, okay, -7, okay, and -21. All right, so now I will divide the L3, sorry, all right. Now I'll divide the L3 by -7 to get 1 here. So L3 divided by -7, right? So 1 minus 1 2 5 0 1 minus 1 minus 1, and here I get 0 0 1 3, right? I want additionally, okay, to have zeros now, okay, on the columns. Okay, so I will subtract now the L1. Now once I finish, I get it into a triangular. Now I want to get it into the identity matrix. So now I will change the, I will subtract from the line 1. All right, so L1, okay, plus L2. Why? It's to get 0 here, right? So here everything stays the same except the line 1, so it's 1, so I get 0 here. All right, and L1 plus L2, so I get 1, and 5 minus 1, okay, I get 4, I get 0 1 minus 1 0 0 1 minus 1. Okay, now what I want is to get zeros here and 0 here, right? So now this line, the third line, I will subtract this and this from this line, right? So, okay, I will now the L1 minus L3, and here L2, L2, okay, plus L3.
Plus L.
Right, so I get 1, 0, 0. Okay. So L1 minus L3. So here 1. Okay. 0, 1, 0 plus 3 plus minus 1, 2, 0, 0, 1. You get to 3. So this is your x now. Okay, x is equal 1, 2, 3. And you can verify if you multiply this matrix A by X, you should get this. Okay, now the interesting thing about the Gauss-Jordan method is that also, okay, you can calculate the inverse of the matrix this way. Okay, so يعني, if what we are doing here, I repeat, is that we are doing a set of operation on a matrix, so subtraction of lines, subtraction of column, etc. And this is equivalent of multiplying by some matrix. When you make subtraction of lines and column, you make so if you make subtraction of lines and columns of lines such as you have okay, that the matrix becomes the identity and you're multiplying by a minus 1. Okay, and when you multiply by a minus 1, you get directly, this is your x. Okay, so x is equal to a minus 1 multiplied by b. The same thing is that this means that if we started by إذا أخذنا الماتريكس here, okay, 1 minus 1 2 etc. Okay, 1 minus 1 2, okay, 3 2 1 3 2 1 2 minus 3 minus 2 2 minus 3 minus 2. As a whole, we put the identity matrix. All right, so هون حطينا identity matrix. The operations that makes this matrix diagonal, and that makes this identity. Well, at the end, when you will get this identity, you make the series of operation to make this the identity matrix. This becomes, okay, the a minus 1. Right? And after all these series of operation, okay, إذا حطينا هون الايدنتيتي هون راح يطلع لنا a minus 1. Okay.
Okay.
And I subtract lines such as this becomes the identity matrix. This then becomes the a minus 1.
A minus.
Right. So this is interesting. I mean, the Gauss-Jordan to get the inverse of the matrix. Okay. Now, as for the program, ما راح أعطيكم إياه program للGauss-Jordan, even though I wrote it, the program, but it's okay. We'll not give you for the exam this program, but the principle is the same. So it's the same method than the Gaussian elimination. But at the end, when you come here, when you finish the Gaussian elimination, and you have to add something to the Gaussian elimination, you have to divide by here. All right, all the line to divide it by the AKK, right? So when you finish okay, subtracting, you make this one, so you divide by this AKK. But it's the same thing when you get here, okay? And once you get here, okay, then you will start divide subtracting the lines, but subtracting this line, right? Then subtracting this line, right, with a factor here, this factor such as you get 0 here, right? So, and then you move on to this line and you subtract this line from the rest of the line that are superior to this line. It's the same thing, right? So it's the same thing. It's a bit longer, but it's the same procedure. All right. So now I want to add a remark. All right. As for let it be for the Gaussian elimination or for the Gauss-Jordan. Okay. So we have um, one problem that can appear. Okay, is that when you do, I'll just share here. Okay, when you apply the program here, you're dividing by AKK, right? So what happens if your AKK equals 0? Okay, for example, you're dealing with a matrix like this, and then you have a 0 here somewhere, right? And then okay, so uh, what you can do, okay, when your AKK equals 0, okay, is to switch the lines, right?
Mm-hmm.
So if you come and you want to divide, okay, by some value, and okay, and what you can do is uh, to avoid problem, okay, is that yeah, there's different strategies, right? So it's called pivoting strategies. The pivot is this AKK here, right? So masalan, one of the strategies that's no, I use that is the most simple, right? So is that, and when I come, for example, on the step A, I test the AKK. So if AKK equals 0, okay, I switch with the next line, okay. يعني I switch the two line يعني هاللاين بتصير هاللاين وهاللاين بتصير هاللاين. All right. And I do this while AKK is different than 0, right? Because the new AKK, okay, if I when I switch, okay, I will get 0, then I will switch with the next line. Okay, بعد إذا هيدي طلعت كمان 0, I will switch with the next one. So this is a very simple strategy, okay? So one of the method is to switch, okay, with the, okay, next line till, okay, AKK is different than 0. Okay, and there is another also method that is called partial pivoting. Okay, so let's say you come here, okay, you test, in fact, okay, so let's say at the step K, okay, your matrix is A11, A1M, yeah, A1M, and then here, okay, at the step K, okay, or step K minus 1, okay, you get here. Okay, so let's say at the second step, okay, here, okay, we have zeros here, and then here we have a to n. Okay, so we want to divide with this value. So one of the method is to search for the line that has the maximum AKK, right? And to switch to order the line according to the maximum of the AKK, right? يعني يعني we rearrange the lines such as here you have the maximum, and to sort the line according to the maximum value of the AKK. Okay, sort the values according to the maximum value of AKK. Okay, so and the last method, okay, which is called absolute pivoting. The only thing here when you do a partial pivoting, okay, is that when you exchange the lines, you exchange the b's also, right? So after you need to remember that, okay, you exchange the lines, and then your values, the value for b, okay, you have to reorder, okay, the x, and if I exchange the line one, مثلا 2 and 3, okay, then the b1 b2 b3. Hello. اوكي، انا اللي كنت عم اقوله انه you need to be assured that this AKK is different than zero, right?
Mm-hmm.
So what you can do is, like, if you find that you, while you enter the loop on k, you put if AKK is equal 0, all right? I switch all the line, all the coefficient with the next line till while AKK, is different than 0, right? Okay, instead of putting if, I can put while, okay, while AKK different than 0, I switch all the line, okay, k with the line, for example, k plus 1. Right? So يعني new AKK becomes the AKK تبع line a plus 1, and I do that till AKK different than 0. So this is one of the methods. Okay. Another method is partial pivoting. يعني we will find the line that has the largest AKK at every time, and then we will switch the line. We'll put this line at the position K. يعني إذا هاي طلعت أكبر وحدة هون حتى هون. Okay. So هلا in all the cases when you switch the lines, for example, إذا هيدا vector B, okay, when you switch, for example, the line 2 and 3, right? So B1 becomes B3 and the B2 becomes, okay, the B3 becomes B2 and B2 becomes B3. So you need to, at the end, when you get your vector X, okay, to know what are, how to switch again all the lines. So you get, okay, X1, X2, X3, because here at the end, بس تخلصوا مثلا, if you switch one time the lines 2 and 3, what you will get is X1, X3, X2 instead of X1, X2, X3. So you need to switch the lines تبع the X, right? Now you have also the absolute pivoting. It's the absolute pivoting here, where you will search not only for the maximum of the line, but the maximum of the column. يعني إذا مثلا طلع, we search for all the elements. هلا this is not very much used, but إنه the absolute pivoting مثلا إذا هون مثلا A42 is the maximum value of all this remaining matrix. I switch not only the line حتى هون, okay, this line, but I switch the column also that A42 يصير هون, okay. But this means that you apply some operation to the matrix, okay, and you need at the end, and you get the result to apply the same operation to the vector X, okay. So this is a little bit more complicated. Root maximum value of the remaining matrix. Okay, and we switch not only the column, the line, but the column also. Okay, such as the AKK becomes the maximum value, and as I had A42, okay, I will switch the line 4 and 2. I will switch also the column, okay, 4 and 2, so the A42 becomes here. Okay? But this means that you apply an operation to your matrix, and you need to apply this operation after to your vector X. Okay, so this is not much more, no, it's more complicated to use. And what I use is generally is this one. So if my KK is 0, I switch with the next line till, okay, my AKK becomes different than 0. This is better in terms of precision because more your AKK is large, better it is. But in general, what I do is that I just see if it's different than 0 and switch with the different line. All right. Okay. So يعني here in the program, all right, so you need to put a while loop. Okay, here in the program, you put here a while loop, right? So here, while here, a k k different than 0. Here you put your while loop. This I think. Yeah. And okay, so if AKK equals 0, then I switch all the lines. So A, here let's go A. I should even put this here. Right, so in any case, this should come in front of this. Okay, so AK 2 point is equal to AK. Okay, I will call it D, for example. AK plus 1 equals C, for example. And then you switch them. So AK equals C, A plus 1. Right, so you can do that, right? So while it's okay, so you can do that. But the thing is, command that you need to save the changes. يعني إذا عملنا changes على let's run this and verify that it's correct. What I did wrong. There's some mistake here. Right. It's big A.
مش المفروض تكون while AKK is equal to 0 أو لا؟
Yeah, it's equal. Yes, sorry. Right. Okay, now it's correct. Okay, well, but the thing is that you need to be careful here at the end, okay, to know if you switch the lines, okay, يعني, you have to save the modification on the lines. But this here you can even know what modification he did on the lines just by as عملت A multiply by X. Okay, if I get my here I get sorry, X prime. So if I make A multiply by X, I should get the vector here right? 5, 10, minus 10. If I get 5 minus 10, 10, yani, okay, the x2 is the x3 and the x3 is the x2, right? This is just this. Okay, it means that I switch the two in the column representation. All right.
Okay.
Okay, so or you have to save the lines and then apply this on the x at the end to display the x. Okay, or you save the lines that you switched. You can make a vector, say okay, I and save the line. I switch the line 2 and 3, then okay, I put some vector to see what are the operation, what are the line that I switched. Okay, I can save them. All right. Now we will talk about the LU method. Okay, a new method. It's called the LU method. So the LU method consists of converting the matrix A into, okay, a product of a lower triangular matrix and an upper triangular matrix. So LU, okay, is, I mean, denotes lower triangular and upper triangular. So into a product of a lower triangular matrix. We can always do that, and we can always convert any matrix A into a product of a lower triangular by an upper triangular matrix. Okay. So I write my matrix as LU. A is LU, and the objective of the LU method is to determine the matrices L, or the element of the matrix L, and the elements of the matrix U. So once you determine, okay, given the matrix A, you determine the matrix L and the matrix U, and then after you need just to solve two upper and lower, one upper and one lower triangular system of equation, which are easy to solve, and then you get your answer. So if I have AX equals B, then if I express my matrix A as a product of LU, right, X equals B. Now if I call this here Y, vector Y, then I get two equations. I get Ly is equal to B, and okay, Lx, Ux is equal to Y, right? So you first solve Ly is equal to B, you get Y, and then we solve Ux is equal to Y, and we get X, okay? Where L is a lower triangular matrix, U is an upper triangular matrix. So these two systems of equation are easy to solve, right? So the only trick of the only difficulty of the LU is to determine the matrix L and the matrix U. So there is several methods. The first of all, the Crout method. The Crout method, okay. consists of expressing, okay, in the matrix L, the lower triangular, we take it as 1 on the diagonal. Why? Because, so we want that, for example, okay, want to express, okay, so I have L11, L22, LNN, so this is my lower triangular, L21, okay, LN1, etc. So this is my matrix L. I want to find these elements, and I want to find the elements of the matrix L and the elements of the matrix U. All right, so okay, so U 1 1. Okay, and so U11, U12, U1N. Okay, this is the upper triangular, U22, U2N. Okay. 0, 0. All right. So the thing is that this L and U, all right, are not unique because here, okay, so if you divide this coefficient by k and you multiply this coefficient here by k, you will get the same result. Okay, on the diagonals, if I divide by a constant here and then multiply here by a constant, then I get the same result. So the crude method correspond to put on the upper triangular matrix here, okay, ones here for the upper triangular, okay. This is always possible. We can put 1 for the lower triangular. This is another method, okay. But I mean, you can either put ones here or ones here, because if you, like I said, if you divide by a constant here, okay, or you multiply here by a constant, you get the same result, okay. If you, again, you multiply all your matrix K, let's say, by some value, by some constant, or you multiply, or and you divide here by the constant, the matrix L, then you get the same result, okay. So in order to define the matrix from a unique way, okay, one of the method consists of putting 1 here on the diagonal of the U. You can either put 1 on the diagonal of the L. So you get, all right, so so the crude method, عم تسمعوني؟ Hello?
Yes, yes, yes.
Okay, so we have, we put the consist of taking 1 on the diagonal. All right, so now we will see how to determine the elements L, okay, and U. So just like I will put, so my matrix A, so is A11, okay, A12, A1N, AN1, ANN. So I want to find the elements here, L11, L22, okay, LNN, zeros here, okay. And now I'll put here for U on the diagonal, I will put 1 here, okay. And here U21, U2N, Okay, etc. Uh, sorry, it's U1 to U1 to U1N, etc. Okay. Okay, so now what's the methods to determine, in fact, the elements? Okay, so the method is systematic here for the crude method. Okay, so I multiply. Okay, first I start by determining. Okay, so first we determine the first column, okay, of L, okay, and these values by multiplying, right? We determine the first column of L by multiplying L by the first column of U. I multiply now, yani I start by determining these, right? So here I have 0, 0, 0. Okay, the first column of U is this one, right? So now if I multiply all the matrix L, all right, yani, by the first column, and I determine the elements, these elements, right? So basically, if you multiply now, okay, so what you get is L11 equals to A11,
Mhm.
right? Okay, now L21, okay, is equal to A21, etc. Ln1 is equal an1, right?
Okay.
Okay, this is okay. Now we continue. Okay, at every step we multiply the first column of L. Okay, the L by the first column of U, and then we multiply. Okay, the first line of L by U, and to determine, yani, we determine like this: this first column of L, first line of U, second line column of L, second column of U, etc. Systematically, we can determine all the elements this way. All right. So this is important after when you want to write the program to determine these elements, the matrices L and U, is to use this method systematically. Right. So to determine the first column of uh, L, right, then to determine the first line of U. Now we determine the first line of U by multiplying what L, right? The first line of L by U. And if you multiply this line by U, right? You get these, yani you get these elements. So now you get L11, right? So you get L11 equals A11. This we already know it. So this is right. So right, it doesn't. So this we don't need even to, right, do it again, right? And now you get that L21 plus L22 U12, right? Okay. Now we are multiplying L by the first line of U to get these elements, okay, which are equal to these elements of the matrix. So L21 multiplied by U12, right, plus L22 so all right, so L21 plus, okay, L22 U12 is equal to what? I'm doing this, multiply by, right, by this line is equal to A22, right? And I continue here, okay, for the last element, till the last element. So it's Ln1. Okay, so now here I can determine U12. Okay, so U12 is equal L21. Okay. Uh, oh, what I did here? No, sorry. What I did. So it's the first line. Okay, the first line of L by U. Okay, the first line of L by U. Right. So yeah, I made a mistake here. So it's now I'm multiplying this. So it's L12 U12 is equal to I jumped to something else here, right? To the second step here. Sorry. I'm sorry for that. Okay. Okay, so what I'm doing now is L by the first line of U. So okay, first line of L by U. So I get L11 U12 is equal to A12. Right, and then I determine U12 here is equal to A12 divided by L12. Right, and then I continue here the same thing. It's L1N U1 L1N U1N is equal to A1N, okay, UN1. Okay, is equal to A1N, yani A1N is equal to U1N, sorry, U1N is equal to A1N over L1. So these ones, I already determined them here, the L12 from the step before. Sorry, it's L11 here. sorry. Okay, the L11 I determined it from the step before, so it's L11 here. Yeah, sorry for that. U1N, now it's correct. Okay, this index must be the same of this one, and this one must be the same of this one. Okay, so it's right, so U1N is equal to A1N over L1N. Okay, now it's correct. And now for the second step, you do the same thing. So L by the second column of U, okay, and then you make, okay, the first line of L by U, at the second line of L by U. All right. So when you do, so this was the first step. I determined here, okay, the first column of L and then the first column line of U. Now I will determine, okay, the Ln2 here. All right. So these coefficient here. Okay, by multiplying now L by the second column of U. So when now I multiply, so the second step here. So these all was the first step. The first step I determined this column and this line. Now I will determine this column and this line, right? So if I multiply now L by the second column of U, turn these coefficients, right? So I get, okay. All right, so let's start by this line. All right, so L12, U12 is A12. This we already know, right? U12 is A12. This already we know that, right? So we don't need even that. Okay. The second okay element here is we get L21 U12 plus L22 is equal to A22. Okay, so okay, when we multiply this, so we get L21 U12 plus L22 is equal to A22 here, these elements, right? So here you can determine now, okay, this U12, you know it, this L21, you know it also, all right? So we determine here the L21 till N1 here, right? So the um, this the unknown is the L22 here, right? Okay, so the L22 is equal to A22 minus L21 U12, right? And you continue here. So okay, the same. You continue the same procedure here. So Ln1 U12 plus okay L here okay, so yes is equal to A and 2, right? يعني L and 2 is equal as L and 2, sorry, is equal Ln1 U12, okay, minus, or yeah, AN2 minus Ln1 U12. Right. So, etc. And now I determined all the seconds column here, right? L22 till Ln2, right? And now I can determine now the second line of U here, right? So these elements, so U23 till U2N now, right? By, okay, multiplying, by multiplying the second line of L by U. Right? So that when I right, and now I determine these coefficients. The second line of L by U. So here you get the same thing, L21, right, is equal either. And then here L21 plus U12 plus L22 is equal to A2. So third here, okay, line is interesting. So this is the U13, right? So um, it's this element here. Okay, so L1 U13 plus L22 U23 is equal to A23. Okay, and then I determine the U23 here. Okay,
Okay.
and then you continue like this. You continue by, okay, the, okay, the line and columns. The first the first column of L, okay, L by the first column of U, but then first line of L by U, but then second L by second column of U, okay, first line of second line of L by U, okay. So here when you do that, here you get the U23, all right. So let's write it. So you get for L21 U3